Hello students and welcome to the quick solution of All India Cast Test Series JEE Main 2019 Test 7 Code A and B Physics. Let's move to question number 1. In question number 1, the density of a wooden sheet is 800 kg per meter cube and its thickness is 5 cm. To what minimum depth below the water level will the wooden sheet sink if it is placed into water? This is the level of water and this sheet is kept in the water. So let h is the depth by which the sheet is sink in the water. So if the sheet is in equilibrium, then we can say that the gravitational force of the sheet is balanced by the buoyancy by the water. So I can write the buoyancy force is, if I consider the cross-sectional area is A, then A into H into density of water into G, that is the buoyancy, must be equal to mg, that is A into T, because T is the thickness of the sheet, into density of the sheet, that is the density of material, into G. So from here we can calculate the value of H. It comes out to be density of material upon density of water into T. So if I substitute the data, density of material is 800 kg per meter cube, density of water is 1000 and thickness is 5 cm. So if I solve this, it comes out to be 4 cm. So option 2 is the correct answer. Let's move to question number 2. In question number 2, a ball is projected with a speed of 2 meter per second with respect to a trolley which is moving with 4 meter per second as shown. The angle at which ball is projected with respect to horizontal in ground frame is. So we can say that the velocity of ball with respect to ground is equal to velocity of ball with respect to trolley plus velocity of trolley with respect to ground frame. So if I write this, the velocity of ball with respect to trolley is 2 cos 60 degree I cap plus 2 sin 60 degree j cap plus velocity of trolley with respect to ground is 4 into I cap. So if I solve this, it comes out to be 5 I cap plus root 3 j cap. So I can say that this is root 3, this is 5. So if this angle is phi, then this is under root 18. So tan phi is equal to root 3 by 28. So from here we can say that tan phi is equal to root 3 by 5 and sin phi is equal to under root of 3 by 28. So if I check the options, then option 3 is the correct answer. So the correct answer for question number 2 is option 3. Let's move to question number 3. In question number 3, a cyclist rides his bicycle at a constant speed of 10 km per hour along a road which is parallel to the railway track. The trains which move in the same direction as the cyclist overtake him in 20 minutes time interval, and the trains which move in the opposite direction as the cyclist meet the cyclist in 10 minutes time interval. The average speed of the trains are. Assume that the trains are moving with the same speed. So if I analyze the situation, this is the track on which the cycle is moving, and at some instant of time the cycle is at this position, and on the railway track this train is moving in this direction with a speed v, and from this direction another train is moving in this direction with same speed v, and this cyclist is moving in this direction with a speed of 10 km per hour. Then we have to find out what is the value of v. It is given in the question that the trains which moves in the same direction as the cyclist overtakes him 20 minutes time interval, and the trains which moves in the opposite direction as the cyclist meet the cyclist in 10 minutes time interval. So from this we can analyze that the consecutive distance between the two trains are same, and if I analyze the situation in the frame of the C, if I keep this at rest, then this train is moving in this direction with a speed of v minus c, and this train is moving in this direction with a speed of v plus c. So these are the relative velocity of the trains with respect to cyclist. So now we can write v minus c that is the relative velocity of this train in this direction, into the time taken by the train is 20 minutes. So 20 by 60 is equal to V plus C into 10 by 60. So if I solve this, the value of V comes out to be 3 times C. Since the value of C is 10 km per hour, so this is equal to 30 km per hour. So option 4 is the correct answer. Let's move to question number 4. In question number 4, two converging thin lengths of focal length 2f and two diverging thin lengths of focal length f are placed alternately along same principal axis as shown. A parallel beam of light of intensity I0 passes through the system of lenses. The intensity of the emerging rays is, assuming the rays are paraxial in nature. Let, if r is the radius of this parallel beam, then since the focal length of this is 2f, so this is going to focus at this point. So the ray diagram is like this. But at the moment when these rays are incident on this diverging lens of focal length f, since they are about to focus at this point, which is the focal point of this lens, so the incident rays becomes now parallel. So this will move in this direction. So let the radius at this incidence is r dash. So if this angle is let phi, then we can say that tan phi is equal to r dash upon f is equal to r upon 2f. So from these two triangles we can say that tan phi is equal to this much. So from here the value of r dash comes out to be r by 2. Now the same exercise will repeat again. So we can say that now these are going to focus at this point, and again they becomes parallel. So effectively we can say that the radius of the emerging rays is r by 2 by 2, that is equal to r by 4. Now the power or energy per unit time incident on this cross section or on this cross section will remain same. So we can say that intensity into pi r square must be equal to constant. So from here the incident light intensity is I0. So we can say that I0 into r square is equal to I final into r by 4 whole square. So from here the value of I final comes out to be 16 times I0. So option 2 is the correct answer. So the correct answer for question number 4 is option 2. Let's move to question number 5. In question number 5, 2 liters of water initially at a temperature of 20 degrees centigrade was heated for 10 minutes by immersion heater rated 500 watt. Due to this, the temperature of the water increased to 42.5 degrees Celsius. The efficiency of the process is, and it is given in the question, specific heat of water is 4.2 joule per gram degree Celsius. The data which is given in the question is volume is 2 liter. So if I convert into meter cube, it can be written as 2 into 10 to the power minus 3 meter cube. Density of water is 1000 kilogram per meter cube. So I can say that the mass of the water is V into rho. So it comes out to be 2 kg. Delta T is 42.5 minus 20. So it comes out to be 22.5 degree Celsius. Power is given in the question P, that is 500 watt, and time is given, that is equal to 10 into 60 seconds. Now we have to calculate the efficiency. The specific heat of water is S is equal to 4.2 joule per gram degree Celsius. So I can write this in this way: 4.2 into 10 raised to the power 3 joule per kilogram degree Celsius. So if eta is the efficiency, then eta into P must be equal to ms delta T divided by T. So from here we can calculate the value of eta. So eta comes out to be m 2 into S, that is 4.2 into 10 raised to the power 3 into delta T, that is 22.5 divided by T, so that is 10 into 60, and the value of P is 500. So if I solve this, it comes out to be 0.63. So in terms of percentage, the efficiency will be 63%. So option 3 is the correct answer. Let's move to question number 6.